Okay, welcome to the section on electromagnetism. And electromagnetism, well, the electromagnetic force is one of the most fundamental forces in the universe. It's one of the four fundamental forces. And what we're going to be dealing with is we're going to be dealing with electricity. And there's two types of electricity. Well, there's the basic electricity we talk about, which is moving charge. And there's static electricity, which is non-moving charge, hence static. But the first question is, what is charge? And what we know is there's two types of charge. There's positive charge and there's negative charge. Now this is standard abbreviation for positive. You'll see this abbreviation a lot. And negative. And in the standard universe, protons, if you look at an atom's of course broken up into electrons and protons and neutrons. Protons have a positive charge and electrons have a negative charge. So these two types of things tend to make up pretty much everything in the universe. The other type of subatomic particle which we get is actually a neutron, which is made up of a proton and an electron. And hopefully, as you can see, if this is proton's positive and it's negative, hopefully that comes to zero, but that cancels out. Anyway, that's what we're doing. As a general rule, like charges repel. Charges repel, just like magnets. If you have two like charges, like two positive, then they're going to repel. And if you've got unlike charges, like a positive and a negative, they're going to attract. And that tends to happen in the atoms and things. You have nucleus full of protons, and then they're going to attract electrons until they're a neutral charge. So next question is charge. Well, let's talk about the unit of charge first of all. The unit of charge, the symbol for charge is Q, or sometimes little q, and the unit is going to be Coulomb. And we draw that as a C, capital C, because Coulomb is a real person. Please note, when you're doing Celsius, you always put a degree symbol next to it, degrees Celsius. This tells us, if we see that, we know that's C Celsius. If there's no degree symbol there, it's going to be Coulomb. So the base unit charge is a Coulomb. That's cool. But how many charges is that? And what we know is that with protons and electrons, there's what we call an elementary charge. The elementary charge is the smallest amount of charge. It's the smallest amount of charge you can have. So basically, it is basically the elementary charge is the same charge as a proton or an electron. The difference being whether it's positive or negative. So the elementary charge is the smallest amount that you can have. So how many elementary charges in a Coulomb? Well, one Coulomb, one elementary charge equals 1.602 times 10 to the negative 19 coulombs. Or, if we just use a calculator, we can do this. 1.602 negative 19 equals, take the inverse. So that means that 1 Coulomb has 6.242 times 10 to the 18 electrons or protons. depending whether it's positive plus Coulomb or minus Coulomb. So basically, if you count sitting there and you count 6.242 times 10 to the 18, or 6.242 million electrons go past, there's 1 Coulomb of charge. And strangely enough, 1 Coulomb of charge is actually a very large amount of charge to have separated charge, because unlike charges, positive and negative charges attract, it's very hard to separate them. So 1 Coulomb of separated charge is actually a very good amount. Now, what we can have is some atoms, like metals, like copper, have have a whole lot of electrons there, but they're loosely attached. So these electrons can move very easily. So when that happens, that means charge for copper, and charge moves easily. And so we call this a conductor. So it conducts electricity. So one of the definitions of a metal is metals should be conductors. Another type of material that we get is what's a nice, no, let's take silicon dioxide. Let's take rubber. This is a classic one. Rubber's made up of molecules, and in these molecules the charges are very tightly held to the molecule. That means these charges can't move. And as electricity is moving charge, or electrical current is moving charge does not move, or does not move easily. We call this an insulator. So if it can move freely, it's a conductor. If it can't, if charge will not flow through it easily, it's an insulator. And well, there's actually a third type of material nowadays, which is basically when you have a whole lot of atoms, for example, and normally they will not conduct, but if you put a field or something on there, it will conduct. So if you can change the conductivity of this material at your discretion, it's called a semiconductor. So a semiconductor can act like as a conductor, and it can act like an insulator. And the important thing is, with the semiconductor, it's able to switch between those two things. Now, let's shift on section 4.2. Let's get this page up. So what we're going to do is talk a little bit about conservation of charge. So one of those things is, unless you actually physically destroy matter using something like an Einstein special relativity, charge is always conserved. So if you start off with a certain number of charges, at the end you'll end up with the same amount of charges. So the net charge is always going to be the same. But so let's take an example. If we have a neutral charge, Q equals 0. Isn't that cool? 0 coulombs. Now, what happens if I have, I don't know, let's take a lithium atom. A lithium atom has 3 protons. And what happens if I have 3 electrons? So if I go, what's the total charge? Charge is equal to 3 plus 3 elementary charge. Plus negative, so I use the elementary charge in this case, electrons are the same size as a proton, but they've got the negative sign plus negative 3 elementary charge equals, so plus 3 minus 3 equals 0, so neutral. Now the thing about an atom, if it is neutral, we call, actually in science we call that an atom. If it is not neutral, say it's positive or negative, then we call it an ion. So let's take example 4.1 or exercise 4.1. An oxygen atom contains 8 protons and 8 electrons. Oxygen equals 8 protons and 8 electrons. Now, what's the charge there? So Q equals plus 8 elementary charge minus 8 elementary charge equals 0, so neutral. And as the joke says, the oxygen atom goes into the bar and says, I think I've lost an atom, and the bartender, goes into the bar and says, I think I've lost an electron. And the bartender goes, are you sure? And the atom goes, I'm positive. That's a really bad joke, I admit it. So that's an atom, but say we ionize it. So what I do is I take out the electron, like I was saying in that bad joke. What happens now? So now what we have is Q is equal to plus 8 electrons plus negative 7 elementary charge equals, so that the elementary charge is equal to plus 1 elementary charge. Elementary charge, not electron volt. So what's that actually equal to as a charge? So 1e equals, we had it just before, 1.602 times 10 to the negative 19 coulombs. So for exercise 4.1, if I remove 1 electron, I end up with a positive charge of 1.602 coulombs.